Japan's automotive manufacturing sector produces and exports millions of vehicles annually through a highly optimized global supply chain. This chart shows the trade disparity between Japan and the United States in 2025. While Japan exported 1.35 million vehicles to the U.S., America sent only 18,624 cars back, a 72-to-1 imbalance. Major manufacturers like Toyota and Honda manage this volume by building left-hand drive cars specifically for the U.S. market before they ever leave the factory. But an estimated $2.1 billion gray market exists for authentic Japanese domestic market vehicles, cars originally built exclusively for the Japanese road system. Under the 49 U.S. Code Section 30112, once a car reaches 25 years of age, it becomes exempt from federal motor vehicle safety standards, allowing these specific models to enter the U.S. legally. These trade rules solve the legal hurdle, but they leave the physical one. Because these cars are built for right-hand drive, they are difficult to navigate within American infrastructure. Sitting in the original driver's seat of a Japanese import makes it difficult to judge oncoming traffic or merge safely into a left-hand drive traffic flow. Correcting this position is an expensive undertaking, with professional conversions costing between $7,600 and $17,000. That price reflects the complexity of the work, requiring an invasive deconstruction of the vehicle's entire front interior and engine bay. A professional shop will spend up to 75 hours of labor modifying 7 critical vehicle systems to reverse the driver's layout. Simply moving the steering wheel is insufficient. The process requires rebuilding the underlying structural and geometric framework of the car. The most critical mechanical step is replacing the steering rack and pinion. The original unit must be replaced with a mirror image rack to reverse the directional control for a left-hand drive position. The setup maintains Ackerman's steering geometry, turning the inner wheel sharper than the outer wheel to prevent tire drag. The new pinion gear must mesh with the rack at exactly 14.5 degrees, otherwise the handling will deviate from the original design. Relocating the steering column involves cutting through the steel firewall and welding new brackets to support the relocated pedal box. While the structural work is being completed, the vehicle's electrical systems must also be completely remapped. Modern engine control units use hard-coded logic that assumes a specific driver position. Advanced driver assistance systems, like lane keep assist and parking sensors, provide incorrect data if the software isn't updated for the new driver position. The airbag system also requires recalibration, as the deployment sequence for the driver and passenger modules is position-specific. The final mechanical step is a mandatory 4-wheel alignment, which must bring the car back to within 1 millimeter of factory tolerances. A completed mechanical and digital conversion is only half of the requirement. The vehicle must also provide the specific technical evidence needed to pass federal inspections. The last hurdle is providing proof to the NHTSA and Customs and Border Protection that the modified vehicle meets federal safety standards. The JDM import industry has historically relied on manual, handwritten documentation, which frequently leads to missing data in compliance records. This lack of traceability creates a liability risk. If a component fails, there is often no central record of the part's origin or the specific torque values used during its installation. As the volume of imports increases, the market requires an enterprise-level digital solution to track the conversion process. QT Drive Innovations serves as a digital backbone by linking mechanical work directly to regulatory compliance. Their QT socket tag system uses near-field communication to track components. A mechanic taps a smartphone to the part to log its installation and specifications instantly. The software utilizes 3D scanning to document structural modifications, allowing for a direct comparison of the firewall integrity before and after the conversion. This data is used to automatically generate compliance reports for customs agents and safety regulators. This digital efficiency allows conversion operations to handle larger batches of vehicles simultaneously, increasing the flow of certified imports to the market. Standardizing the tracking of every weld and component allows the JDM import market to move past manual paperwork and operate at a global industrial scale.